Okay, in this video we will continue on the pH measurement, which is subchapter 2.1.6. Okay, let's have a look the objective and topic covered. So basically the objective is to describe the importance of pH measurement and to explain standard hydrogen reference electrode, type of meter, pH electrode, how the pH is measured. In this topic, we will cover on the introduction to pH measurement and pH measuring system. So as per introduction, pH measurement is done by comparing the potential of solutions with unknown hydrogen ion to a known reference potential. So this one I will explain in details in the next slide. So basically we will compare the hydrogen ion activity of the measured solution with the reference solution, the hydrogen ion activity. So the greater the concentration of hydrogen, the more acidic the solution, and the pH will be lower. So for the neutral solution, normally the pH is 7. So why this pH measurement is very important? Because this pH measurement is used in a variety of application. For example, agriculture, wastewater treatment, environmental monitoring, and also research and development. So basically, for us, the most we will play around for the chemical engineering. They will play around pH inside the wastewater treatment and also environmental monitoring, because in order to control the effluent coming out from the plant, we need to control the pH of the solution of the fluid, a solution of fluid that coming out from our plant, so that our unwanted or our waste from our plant is not harm to nearby residential area or nearby ecosystem. Okay, so a standard pH measuring system consists of 3 elements, which is pH electrode, temperature compensation element, and pH meter or controller. So now I will explain on the pH measurement system. So okay, so basically this is the equipment for the pH measurement. So the concept that used by this pH measurement is same like electrolysis that you learn inside the electrochemistry. If I'm not mistaken, this electrochemistry is being taught inside your SPM syllabus. So now I will explain one by one the apparatus that consists inside this system. So first is solution being tested, which is the blue solution. So this one we need to measure the pH. So the second one is glass electrode. So basically this is the glass electrode, set of glass electrode. So at this glass electrode, number 3, there is a thin layer of silica glass here, the grey one. This silica glass containing metal salt. Inside this silica glass, which is number 4, our internal electrode, this one, which is our solution inside the internal electrode, is potassium chloride solution. Okay, this is our internal electrode and it is made from silver chloride. So number 6 is hydrogen ion formed in the test solution. So here is a hydrogen ion that will form inside the test solution due to the interaction of the ion inside the solution and also at the outer surface of this glass. And inside this glass electrode also form hydrogen ion. This is due to interaction of the potassium chloride solution with the inside surface of the glass. So we have a meter to measure difference in voltage between these two electrodes. So after we measure this voltage, we can get potential difference. This potential difference will be converted into the pH reading. Then we can know the pH of this blue solution. So we have number 9 is a reference electrode. So this reference electrode basically is a basis for this electrolysis system. Okay, now I will explain one by one on how this system can measure the pH. So basically we have a potassium chloride, the orange color one. The pH of this potassium chloride is 7. It is a neutral solution. So this neutral solution have its certain amount of hydrogen ions. So this blue solution is an unknown solution. Supposedly this blue solution is much more acidic and it contains a lot more hydrogen as compared to this orange solution. So the function of this glass rod is to measure difference in pH between this orange solution and also the blue solution by measuring its voltage. So this voltage is depend on the amount of hydrogen ion produced in both solution. So okay, when these two electrode, this one and this one, is dipped into the blue test solution, so some of the ion of the hydrogen ion inside the blue solution will move toward the surface of this glass rod, while some metal ion move from the glass rod into the blue solution. So we have two way of ion exchange, one attached to here and one will go to the blue solution. This ion exchange also occur inside the orange solution. So this ion exchange is it will create a different degree of hydrogen ion activity on the two surface of the glass, which means different amount of electrical charge will build up on them. So this different degree of hydrogen ion activity can cause a change in a voltage. So it's appear between two sides of the glass, which produce a difference in voltage between silver electrode here, this silver electrode, and also this reference electrode, because there is a ion swapping occur inside here. That's why there is a difference of voltage can be read here. So basically, although meter number 8 just now measuring voltage, but the pointer on the scale actually show us a pH measurement. Okay, for your information, the bigger the difference in voltage between the orange and blue solution, the bigger the difference in hydrogen ion activity. So if there is more hydrogen ion activity in the blue solution, so the solution is acidic, and the meter will show lower pH. In the same way, if there is a less hydrogen ion activity in the blue solution, the meter show as a higher pH. So the solution is alkaline. Okay, so now we move to standard hydrogen reference. So basically, this is the example of half of the electrolysis. So if we use a just now we have a we use this one as a reference electrode. In other way, we can use the standard hydrogen reference electrode to be our reference electrode. So basically, this SHE, it consists of platinum wire covered with finely powdered form of platinum. So the electrode behave as a hydrogen electrode. So standard hydrogen potential is that obtained when an electrode is in contact with a solution inside here. So basically, to calculate the electrical potential of this standard SHE, we can use this formula. So basically, E0 is the potential of the electrode in a solution at pH 0. So you need to find the potential of the electrode at the pH 0 first, and then you can calculate the electrical potential. Okay, so this standard hydrogen reference electrode can be used pairing with other type of electrode depend on the system itself. Okay, I will show you a video on this SHE later on so that you can get the understanding. You can get the visual understanding. So, okay, we have other type of pH meter electrode. For example, like quinhydron, antimony, and also glass electrode. So, the characteristic for quinhydron normally limited to pH 8. And it's not commonly used. It can produce some error. Normally, contaminate solution is used to measure using this type of electrode. So, antimony, the pH is around 2 to 12. It cannot be used for solution containing ions metal that is electropositive with antimony. And the solution that we use must be mechanically clean. So for glass electrode, it's the same like I show you in the previous pH measuring system. This is the commonly used glass electrode. It is unaffected by most chemical. Potential difference developed across the glass membrane is proportional to difference in the pH of two solution. And it is measured by putting electrode into each solution. Okay, the other type of the pH device, we can use temperature compensation element. For your information, pH is a function of temperature. pH is a temperature dependence. So pH application requires some form of temperature compensation to ensure the standardized pH value. So, for your information, inside the industry, normally we didn't directly use the pH controller or pH measurement because this pH measurement is quite cost if we use in a large scale, to measure the large amount of fluid. So, in other way around, we will use the temperature compensation element. So, meter and controller with automatic temperature compensation ATC receive a continuous signal from a temperature element and automatically correct the pH value based on the temperature of the solution. So, this is the type of indirect control. That means it control the pH by receive a signal from the temperature element. For the manual temperature compensation, it is required the user to enter the temperature. Basically, ATC is considered to be more practical for most pH application because normally pH measurement or pH controller is quite expensive as compared to temperature. So that's why we prefer to use the temperature compensation element. Okay, so this is a common pH meter that will be used normally inside the R&D lab, laboratory, normally in laboratory, in a small scale production, or in a tested lab. So this pH meter has two basic components, which is the meter here, which can be a moving coil meter, one with a pointer that move against scale, or a digital meter with a numeric display. And the other basic component is one or two probe inserted into the tested solution. So basically the concept that being used for the pH meter is same as the one that I explained before, the electrolysis concept, because they have to probe here, it act as a electrode. So basically this pH meter work like a voltmeter. It will measure the voltage, also known as the electrical potential, produced by the solution whose acidity we're interested in, and it will compare it with the voltage of the known solution, same like I explained before, and it used the difference in the voltage between them to deduce the difference in pH. So basically by defining the voltage, we can measure the pH. So for pH measurement, I think that's all. If you still cannot understand about this, try to look on the video that I will give on the working principle on each of the device that we cover inside this video. Okay, thank you.